Very good evening to everyone. Very good evening to everyone. Welcome to pantechelearning. Day 2 session on A and ML. Conducted by St. Joseph College of Engineering. So in yesterday class we discussed about what is AI, what is machine learning, what is deep learning, and what is NLP. Everything we discussed. So, but we gone through with the application only machine learning based. We see in the application, if you are using AI with the machine learning, then we can use some of the Excel sheets that we discussed yesterday. So now, from this machine learning, we are going to deep learning process in a second day. So in a second day, we have to discuss today what is deep learning, what are the techniques of the deep learning, and how it will work for the real-time applications, and how the construction of layers will be there. And if you want to construct any deep learning models, because machine learning models that are already available, else you can go through with some combinations or combining of models or ensembling models in a machine learning. But now uh, if you want to build any algorithm after machine learning, we should go through with the neural network, and later you can extend some particular layers of the hidden layers in a neural network, that you can say it as a deep learning. So the theory of the deep learning, yesterday we already discussed. If you are using two or more layers, if you are using two or more layers in a hidden layer, that you can say it as a deep learning model. So what is the use also, yesterday we discussed. So again I will give the recap for it. So just simply in a machine learning, you can work for the less amount of the data. But if you want to work for the huge amount of the data, so that is not enough. Then what we should do? So we should forward from machine learning to the deep learning, but that is not directly is possible. So that purpose, from the machine learning we gone through neural network, and later we upgraded neural network with the increasing of the hidden layers, that you can call it as deep learning process. So now we will discuss in-depth wise what is a deep learning. So we know already deep learning is a subset of the machine learning and as well as artificial intelligence. So it can work to get the better accurate results, and it can work to train the database very deeply with all features. We didn't get any features loss most of the time when you are using the deep learning. So we've seen some of the applications. Again, I'm saying to you. So if you want to work for images, videos, audios, Excel sheets, anything, speech recognition based, NLP based, we can work for it. So in real-time applications wise, today we are taking one of the application will be deforestation. Later we will discuss about the application. Now we can see in depth of the deep learning process. So introduction we have already given, but if you want to understand that in depth of the information, definitely we should go through with the neural connection. So yesterday also I said about the neural network construction, how it will work and everything, and how the neurons are connected to each other in a neural network. We discussed very clearly for that, right? So today we are just continuing that with the requirements of construction of the layers. So we can see if you want to start any neural networks, these are the layers, whatever you're seeing. So you can see down arrows. In this, you can see some of the particular area. So this is about what? Whatever you're getting the input, that may be image or video or audio, that you are gathering features into the weight values. That weight values you are giving to the hidden layer, then it hidden layer it will get the features based on the size, shape, color and everything what you're having the features with your database, and finally it will transfer the output features after the classification to the output layer. But it's not possible only with the construction of input layer, hidden layer and output layer. So if you want to construct full of deep learning models along with these layers, we need some bias functions. Later we will discuss what are the bias functions and everything, because a simple theory we are discussing means we can easily understand what is the next step.
So if you want to go with applications wise, yesterday I said already. So these are the steps you have to follow. So yesterday we followed some particular steps about the machine learning application about educational based, right? So like that, if you want to follow in a deep learning, these are the steps. Yesterday shown in a normal, but today we will discuss very in-depth way about this process. So first you have to take some particular problem. So this is about particular requirement to train the database, and you have to identify something from your requirement. So that purpose, first you have to take some particular problem. What is the meaning of the problem here? Understand the problem. For example, you can see previously we don't have the AI option, and we don't have the earbuds, and we don't have the chat GPT, we don't have like AI assistants, Google assistants, something, Siri, Alexa, something we don't have. So what is the thing there? The people want to communicate with the AI using voice or text based on their requirements. So here the problem what we are getting, so we have to give some support to the human being by using of our AI. So that is our main motto. Why you want to do this one means, because we have to reduce the problems who are searching for the content or who are searching for the answers from the online setup. Because if you are searching anything in a Chrome, then it will suggest so many type of sites. So I don't want to get like that. If I'm asking question, the best answer it should give. So that purpose we can use AI part setup here, like Google or Siri, Alexa, something, or any other type of applications. So that is her solution to get a solution for a problem. So that purpose what you are doing here, so you are taking the first one is understand the problem. So understand the problem means what are you seeing the problems in a present situations, the problem statement you have to take. Then later you have to identify the data. Okay, you are taking the problem, that's fine. But if you want to give the solution for your problem, definitely you need to get the past data, that may be images or videos, anything, any type of data you can get. So that purpose, what you want to do, you have to identify the data. So yesterday, how we identify the data from the Kaggle website, we have identified the data. Or else, if you already gathered the data and with your digital cameras or something, or with the Excel sheets, you can say that is identifying the data. Then, like next one, select deep learning algorithm. Okay, you have taken the data set. That's fine. But if you want to complete your process to get the solution after getting the data, then you have to select some particular deep learning model to train your database whatever you have gathered. So that purpose here you have to select some particular deep learning model, that may be CNN, RCNN, GAN model, GRNN, any type of model you can gather. So then later what you want to do, so you have to train the model. Why you have to train the model? So when are you selecting the deep learning model, that is, it's like a empty model. The construction will be empty. So the construction will be available with the two options. You can construct step by step, starting to ending point. Else, you are having already constructed layers from the particular libraries, TensorFlow, Keras, or PyTorch. Okay, so that purpose what you have to do means you have to train the model. So next step. So after training the model, so you have to go through with the test the model. So these are the steps if you want to follow any type of applications in a deep learning. Hope you can understand the steps. So these are the steps. If you want to follow anything, you can follow these steps. So coming to the next one, here now we can start the uh, basic to in-depth neural network process here. So that purpose, what you have to do means the simple thing, you have to understand the construction of the layers. So that is the best thing to construct the models for the applications purpose. So we are seeing the theory only, but if you want to see the practical session, then you have to understand the construction of the layers. So this is about the simple neural network: single input layer, single hidden layer, and single output layer. But coming to the deep neural network, we have to follow the two or more layers. Now we can see each and every neural network how it will works. So you can see today we are taking a database, will be images only. We will work for the images today, and tomorrow NLP will be there, right? So then we can work for NLP with the deep learning or machine learning for the text purpose. So today we are working for the data set as images data set, and we can take any type of data set also, that is not a problem. So here I am taking data set is constructed with a collection of the data, so is nothing but what I am taking. So if you want to start the process, then we have to know which type of data set you have to take. So I have to collect some particular data, some particular websites or from anywhere. So that is the process of the data set. Now you can see how many types of data sets will be there. So whether it is numerical and bivariate or multivariate, so categorical or correlation, any type of data set you can take and you can gather here based on the requirement. So then later what you want to do, you have to train the data set by using the deep learning models, right? So this is the next step. So now you can see the neural network construction. So we can see the definition of the neural network. So neural network is nothing but it's a construction of the neurons to each other with the layers of input layer, hidden layer, and output layer. So it will work for to train the any type of databases with a huge amount of the data. So here you can see the types of the layers. We already discussed input layer, hidden layer, and output layer. Now you can see how it will work the neural networks. So simply you can see here we are giving some basic neural network how it will work. So here you have to take your database. Okay, so number of informations you have to take. That informations will convert into the weight values. How it will convert means the original image will convert into the numerical values, or original image will convert into the some decimal values or something. So that will be possible when you're converting original data into another format of data, example by using of the numpy numerical python or array format of the data. Then later that weight features you should give to the hidden layer, then it will give the output. Why these many connections are there? So why these many connections are there means, for example, you are taking the data and you are giving to this. See, this first H11, you're giving to the all nodes of the hidden layer. This is input layer, this is hidden layer, and this is output layer. So here you are giving from the input layer to hidden layer like this. Okay, so why you want to connect this first one to all layers means, because if you are not getting the features from here to get the output, maybe from here you can get the better features, so or else you can take from here. So like that it can give any type of better option to you. Even it can divide the picture into a different type of features based on the size, shape, color, and everything. Now you can see if you are taking the single neuron, how it can. So if you are taking the single neuron, so here you can see W01234WN is nothing but these are the weight features of your input layer that you are giving to the single neuron. Then what it can do, it can combine the all features of your input picture, then it can give the a better feature for you. That is only you can call it as a single neuron. So coming to next one, how the neural network structure will be there. So I said already, if you are taking any type of the neural network construction layer, so definitely you have to follow these steps. So the input layer will connect it to the hidden layer, and hidden layer will connect it to the output layer. But here you can see, if you are connecting from input layer to hidden layer to the output layer, definitely here in this part you have to use bias functions. That is only the construction of the layer is very important. So most of the requirements with these, we are having so many advantages. What is the meaning of that? Means it's already pre-trained model. You can do the fine tuning by using of new database what you are having exactly. For example, 1 GB data I already trained, but I want to take the new data and I have to work for it, means you can do that. So coming to the next one, huge amount of the data you can work here. That is the second step. And coming to the next step, so you can get the more better accurate result compared with the others. So that is the advantage of this. And here you can see how the neural construction will be there. So before starting the neuron construction, so I just want to tell something and later we can discuss all neural networks what you are having exactly. So here you can see, so here you are having the neurons connection. So these you can say it as a neurons connection, right? So this is exactly what you are constructing the layers to train the database. This is the main part. If you understand these steps, how the steps are coming, then you can easily you can build yourself with the new neural networks. So that is the best thing here. But only the thing, if you want to increase the layers of the hidden layers, then you have to get you have to be with the more huge amount of the space you need. If you don't have that space in your particular area where you're taking, then you can't build a more neural network hidden layers. So if you want to complete any type of constructions, or if you want to train, if you want to understand those problems, actually I said already some particular steps here. What are the particular steps? You have to understand the problem, then later you have to identify the data, selecting of deep learning and training and testing. These steps if you want to follow properly, then the training of the construction, and as well as like if you want to do anything with the neural network construction for training and as well as the testing, these are the main steps. If you want, if you're understanding these four things, then it's easy for you. So here, first thing is you have to take the inputs. That input will convert into the weight feature values that may be using of numpy or something, any other type of particular array values. Okay. Then later that weight features you should take the summation values and you should give to the some particular hidden layer part. Then later what it can do, along with this hidden layer, you have to take some bias functions. In that bias functions, you are having three type of the functions: activation function, loss function, and along with that you are having the optimizers. If you are using these three things, then only you can get the proper output. Why you want to take these bias functions while going to the output layer means, for example, if you are preparing something, okay, if you are I mean if you prepared one product, and if you want to get the product is working in a proper way or not, how to check? So definitely before selling the any type of product, you have to recheck it once, right? Otherwise you will get the negative things from the particular customer to which person you are giving. So that purpose what you want to give means you have to check the product and you have to train in a proper way. So that purpose, so you have to follow the steps. So I will tell you the steps in detailedly how the steps are following. Now you can say this is about the perceptron. So here you are having the different type of weight features and you are giving to the output layer. So here you can see the perceptron process. So now the neural network construction is like this, right? So this is input layer, these are the hidden layers, and this one will be the output layer. Now you can see the layers how it will work: input layer and hidden layer and output layer. So this is the process: input layer, hidden layer and output layer. Okay, if you want to see the multiple layers, you can see the multiple layers. N number of layers you can construct in a hidden layer. So now this is the main thing. Okay, so we will take the definition of first each and everything, then later we can see what is bias, how the steps are going, how many types of bias functions are there, how many types of activation functions there are in a bias, and how many loss functions, what is this activation bias and loss function, and as well as optimizers, means in depth we can discuss now. So that all are required to construct the neural network model, means the deep neural network. So here you can see the first one will be input, weight features, then you have to give to the bias functions along with the weight feature values, then you will get the output, right? So then you should know what is weight, because the weight features are very important if you are giving the weight features to the hidden layer along with the bias functions. Then what is the bias function? What are the activation functions? We can see now. Okay, so the first we can discuss what is weights and bias. So weights is nothing but wherever you're getting the input data, that input data, you're gathering the weight features based on the features of your input. That may be size, shape, color, something, some extra features, that we features you're converting into some exponential values, that you can say it as weight values. So coming to the next one, bias. What is the meaning of the bias? So here you can see if you want to get the output, so you have to take the weight features into input plus bias function, because if you are taking the bias function you will get the better accurate results. So now you can see what will be there with the bias functions. Okay, you can understand now how the weight, bias functions and activation functions will work. For example, you are giving the input weight feature values to the hidden layer, then later here if you want to gather the better accurate results, here before hidden layer and after hidden layer you have to go through with the bias function to get the better accurate results, and you don't want to get the loss of any type of information, and it should be a proper, it should be a better output. For example, you're giving 100% of data in an input side, then you have to get at least some near what is it, approximate results for your database. That purpose you have to use the bias along with some particular functions. Okay, so first you can see uh, in this particular area, so what is forward propagation? So what is the meaning of the forward propagation? Means, for example, you are going from input layer to hidden layer and output layer, this is nothing but the forward propagation. So why I am saying directly all the steps should go like this only, right? So from the input layer to hidden layer to the output layer. No. Sometimes if you are not gathering the proper output, then you should return back to the hidden layer. Again, you have to recheck, then you will get the results. So like that we are having the back propagation and forward propagation. So you are having some particular algorithms with the forward propagation, but with some particular models you are having the back propagation also. So this is the forward propagation, you don't want to come back to the hidden layer. So coming to the next one, this loss function I will say you later. So now you can see the back propagation. What is the meaning of the back propagation? So back propagation is nothing but, so when you're taking your input features and you're going to the hidden layer and you're getting the output layer, but if you're having any some modifications and you're not satisfying your with your output information, then you can go to the return back to the layers. Again you can retrain and you can come to the output layer, that you can say it as a back propagation. Okay, so now we will discuss what are the main steps in construction of the neural networks. I shown you already one particular construction picture. Based on that we have to follow. So now I will say you, if you want to construct any algorithm, the loading of the database, training of the database is next one. But if you want to construct the neural network, what are the steps? So you're seeing this one, but these steps as per requirement purpose, I will show you how it will work. And how to construct the neural network models exactly I will show you here. Okay. So then later I will show you the application wise what are the steps like yesterday. So now here I am taking the construction, the main step I am taking here, construction of deep learning models. If you want to construct any type of deep learning models, then what are the steps you have to follow? That steps I am giving. What is that? First you have to take the input layer. For simple understanding purpose I am giving. Next one you have to take the hidden layer. So coming to the next one, you should take output layer. Then where you want to take the bias functions and all. So here we need to use bias functions. Before hidden layer also we have to use sometimes. So bias functions. Bias functions. What is the meaning of the bias functions? To improve the training, to get the better features, to get the better construction of the deep learning model, we have to use the bias function, right? So that purpose what I want to do means in this bias function we are having the three requirements. The first one will be activation function. Activation function. The coming to the next one, loss function. And third one will be optimizes. So in input layer, you have to get the input data with particular size, with particular size. Then you should convert into weight feature values. That weight features example purpose like W0 to WN you should give to the hidden layer. In hidden layer what you want to do means in hidden layer also some of activation functions you have to give. That may be linear activation function or non-linear activation function you can give. Okay, so these are the steps if you want to get the output of the construction of the neural network. So based on these layers only we have to construct the algorithm part setup of the deep learning model. So first you have to take the input layer, then input layer you have to mention your input data size and later it should convert into particular feature values. Then after that you have to take some hidden layers or something. Then there you have to give some activation layer, functions that may be linear or non-linear. And coming to the next one you have to get the bias functions with the activation, loss function and optimizers. So what is activation, what is loss function, what is optimizer and everything we can see in detail. So we know already what is input layer. We have seen already what is the weight features. We seen already what is the hidden layer. Now we can go through with the bias functions. First one is about the activation. Later you can see the loss function and after that you can see the optimizers. So now I am going through with the presentation. Here I can show you the activation functions. So actually these are the calculations for this. So after completion you will get the presentation. Then we can see the theoretical calculations and practical calculations as well. How you are getting the all values. So now you can see. So why I am going through with the directly activation function here? Because in a construction of the neural network, any type of deep learning model, you know already input layer and hidden layer part. Now you have to see what is activation function and what you are exactly using activation loss function and optimizer. So in bias function step. So when you will get the bias function after hidden layer or with the hidden layer. So that I want to check here. So here you can see some particular activation functions. So we know already what you are doing in a hidden input layer. Simply you are getting the input features, then that input features are constructing with the weight features, then you are giving to the hidden layer, then hidden layer it will grab the features. Then after that you have to connect those features with the activation functions. So what is the meaning of the activation functions means how you need the output, like if you want to take any type of requirements. Okay, so you're having most of the six type of activation functions will be there. So these six type of the activation functions will work for many type of classifications. Okay, so what is that means I will say now. So the first one will be here you can see in a activation functions, why the activation functions are using exactly. What is the meaning of the activation functions means the simple thing, whenever you're working for the features of your input, along with that you have to allocate the bias. So what is the meaning of this activation function means this activation function will work to determine the output of mathematical calculations, and you want to get the better results, maybe yes or no conditions or binary classifications or multiple type of probability classifications, then you have to do the activation function. So that purpose you're taking the activation function. Here you are having many type of activation functions. So sigmoid, TNAH, ReLU, leaky ReLU, softmax and linear. Okay. So what is the meaning of this one means here you are having two type of activation functions, linear activation function and non-linear activation function. Linear activation function is nothing but one by one it will come, it having only in a serial option. But coming to the non-linear function, you're having the probabilistic manner, or you're having like multiple classification purpose. You can use non-linear functions. Means parallel you can get the different type of outputs at a time. That you can say it as a non-linear function. Here you can see in an activation function in starting of your input layer or hidden layer. You have to use the linear activation functions because that are in a linear format, that are in a series format. But coming to the hidden layer and later for the output layer, before the output layer you have to use the non linear functions. Why you have to use the non-linear functions means, for example you are having 100 type of images, 100 images, okay, with the two labels affected and not affected. So then what you should do, you have to read the all features of the pictures one by one, but it can't take the pictures in a linear way. If you're taking in a linear way to gather the features, okay, it's like by adding to the system also. For example, if you're taking one subject, okay, in that 1 2 3 4 questions continuously, first question you are learning, second question you are learning, third question you are learning means in a series format, then you can't maybe you will by heart that one, but you can't get proper answer after 1 month or 2 months. If you want to get the proper answer, you have to understand, you have to swap the questions also. First question you can learn first, then later fourth question you can learn, next third question you can learn. So what is the meaning of this one, you have to do the swapping process. If you are doing the swapping process, then you will get the better accurate results, means the random process you are doing. So randomly you have to identify the features of your input data, then you have to use the non-linear activation functions. If you're using in a linear format, it's like a by heart to the system also. When the construction model is going on, it won't give proper accurate results. But for the starting purpose you have to take the linear, that purpose you're having the linear format. So here you can see remaining sigmoid, TNAH, ReLU, leaky ReLU, and softmax. These are the non-linear activation functions. The first one we can check sigmoid activation function. So most of the neural networks for the image classifications, we can use sigmoid activation function. But the sigmoid activation function will work for only for the binary classifications. If you want to do the binary classifications, yes or no, then you have to use the sigmoid activation function. You can see here. So it's not like a linear. Linear means we know already. How the linear will be? Like this. So you can see only particular line that you can say it as a linear. Example purpose you can say this is a linear process. But coming to the non-linear process, I said all are non-linear. That's why you can see in a sigmoid activation function, it's taking the non-linear activation process to get the construction model of neural network properly. So coming to the next one, as you can see, the comparison you are showing. So next you can see TNAH function. So this is about TANA. So what is the meaning of this TANA function means if you want to create the generate models in deep learning, then you have to take the TNAH. For example, if you want to construct the, if you want to create the fake features from the original features. For example, you are having the 10 pictures. You have to convert the 10 pictures into 20 pictures. Then you have to use the activation function will be TNAH. It's like a nonlinear process only, but it will uh, give the extra features by creating of the new fake features from the original features. For example, in GAN, generative adversarial neural network, you can use this TNAH function. Coming to next one as ReLU function. This is simply the small modification of linear function. You're having the rectified linear unit. So you have to take the some rectification process here. Then later you can see the linear process. Means it's a combination of linear and non-linear. So that's why we can't say this is a linear process. This is rectified linear unit process. So that is also will work for the construction in a hidden layers and output layers also sometimes. Next one, leaky ReLU. So these leaky ReLU will work for the generation models like GAN. So what is the meaning of the leaky ReLU means? You can observe here the first one and second one. So you're having small modification. Some leakage process will be there. So that purpose you can say it as a leaky ReLU function. So coming to next one is softmax activation function. This is main important function if you want to do the multiple classifications. Multiple classifications is nothing but if you are giving one picture, from that particular picture I want to identify all those objects, then you can say it as multiple classification of from the single picture. That purpose you can use a softmax activation function. It's looking like probabilistic manner. Because of the probabilistic manner only, you'll get the better accurate results for the multiple classifications by using of the softmax activation function. So coming to the linear. So linear will work for only either yes or no conditions. It's already available. Linear type of data set it will work. That's it. So now you have seen all activation functions of our neural network construction purpose, right? Then how to select your activation functions? I said some particular theory, but how to select from these particular six activation functions for the construction of the deep learning models? If you want to construct a CNN model, you have to take one type of activation function. If you want to construct RNN, you have to take another type of construction activation function. If you want to construct GAN model of the deep learning, then you have to take some particular activation functions. So based on the theoretical part setup, then you can understand. You can see here. So ReLU, leaky ReLU will work for the hidden layer, and sigmoid will activation function will work for the output layer of the binary classification. For the binary classification, I said already sigmoid you have to take along with that ReLU, leaky ReLU you can take for the hidden layer, not for the output layer, for the hidden layer. So for output layer, you have to take the sigmoid for the binary classification. If you want to do the multiple classifications, multi-classification, then you have to use ReLU, leaky ReLU for the hidden layer purpose, and but for the output layer purpose, you have to use the activation function because you're having the probabilistic process here. You will get the multiple classifications by using of the softmax. So coming to the next one, in case of regression problems, you're having the regression models like machine learning models. You're having only the option linear activation functions. So these are the activation functions what we are taking exactly. Now you understand what is the activation function, I think so. Now in bias function, the next step you can see loss function. What is the meaning of the loss function we can see now. So now we will discuss about the loss function. So these are the main loss functions what are availability. Why these many loss functions will be there? Why these many activation functions will be there means simple thing. If you want to prepare one particular dish, the main ingredients will be there. Along with that extra ingredients you have to add. For example, if you want to prepare what is it non-veg item, then you have to take chicken or fish or something prawns you have to take. If you want to go through with the veg option, then definitely you have to take some veg items, right? So like that, how the requirement will be there to prepare some particular food. Like that, here you want to create any type of deep learning model. So you have to select particular all functions, the required functions. If you're taking another functions, it may work or it will work. So we can't say it work or it won't work. We can't say properly. So that's why for deep learning models based on the construction of the layers, you're having so many of activation functions, you're having so many of loss functions, you're having the different type of optimizers. So now we are discussing second option in bias function, that is about the loss function. Here you can see in a loss function, the first one will be MSE MAE, second one will be binary cross entropy, and third one will be categorical cross entropy. Now we can see what is the MAE and MSE, mean square error and mean absolute error. So wherever you are taking regression models, wherever you are taking classification process for the future generation, then we have to use this MAE and MSE. For example, you're taking linear regression or you're taking regression part in a neural network, then you can take the MAE and MSE. So mean square error and mean absolute error. These are the output parameters. Hope you understand this one. So coming to the next one, binary cross entropy. So binary cross entropy means you can see the name itself, you can understand. If you want to go through the binary classifications, then you can use this binary cross entropy. Now coming to the next one is categorical cross entropy. Categorical cross entropy is nothing but multiple classification you can do. So can I expect something from these activation functions? What I can do on some particular model and what I can take activate loss functions from the particular model. For example, if I want to create the neural network of the CNN, in CNN, you're having the option with multiple classifications. Then what you want to select? From the activation function, I want to select the softmax. From the loss function, I have to select the categorical cross entropy. And for the optimizers, I can select almost same Adam optimizer, Adaboost or something. So I will tell you later. So like that, based on your construction of the models, you have to select. So these are the loss functions. Three type of loss functions will be there. So coming to the last one in bias function, optimizers. Now you can see the optimizers function. So I didn't say about any theoretical part about the loss function. What is the meaning of the loss function means? For example, you're taking 100 images. You're getting the training of the 100 images with some particular features. Then you have to know what is accuracy and what is loss exactly from your particular data. For example, you are taking one subject, 100%. Is it possible to you to complete within a 1 month? If you complete it also, while writing time, you'll get some loss, right? So maybe you're getting 98 marks means that is about 98 percentage. You're getting 55 marks means you have attempt only up to 55 percentage. is nothing but how the percentage is going on. There may be loss or accuracy. You have to identify and you have to get in a proper way to train the model. That purpose you can take the loss function. So coming to next one is third option in bias function optimizers. So you are having two type of optimizers here. So what are the optimizers? From these optimizers, many there, but for the deep learning and machine learning, mostly we are using this gradient descent and as well as Adam optimizer. So Adam optimizer will work for the deep learning layers, means non-linear functions, non-linear type of models. Gradient descent will work for the only for linear process. Why the gradient descent will work only for the linear? Why the Adam optimizer will work for the non-linear process? We can see now. So first you can see the gradient descent. So here you can see whenever you're taking the input features, it will get the output features, but you are having some minimum loss of the features. So that's why you won't take a gradient descent for all those requirements. For less requirements you can take. But coming to the Adam optimizer, if you're taking the Adam optimizer, then you will get better features to boost up the algorithm model for nonlinear models of the deep learning. So for the machine learning purpose, mostly we can use gradient descent, and for the deep learning process, we can use the Adam optimizer. So why you want to use this means here you don't have, I mean, you can see like overfitting and underfitting. Okay, so you're having the overfitting process or underfitting process of your model. What is the meaning of the overfitting and underfitting? The by name itself we can say what is the overfitting and underfitting. Overfitting means so I need 1 GB only, but the data will be there, database will be there 1.5 GB. It's like overfitting process. Example purpose I'm saying. Underfitting is nothing but so I'm having the space as 15 GB, but I'm giving only 1 GB data means it's like underfitting. So here to reduce those problems, we are taking these optimizers based on the requirements. So these are the steps. Now you can see because of these input layer, hidden layer, output layer, because of these bias functions. In bias function you are having activation, loss function and optimizers. Along with this all those requirements we can build the neural networks. In that particular neural network, the first one will be artificial neural network. So this is the one of the neural network process. So what is the meaning of the artificial neural network means? It has only three layers. So that is input layer, hidden layer and output layer. It doesn't have any type of modifications. Then you can say it as artificial neural network. You can see the artificial neural network. The construction is looking like this. So coming to the next one, back propagation neural network. It's like forward, right? Forward propagation type, right? So coming to the back propagation neural network, BPNN. So in this back propagation neural network, you can see some propagation is going to the return back. You can see this is input layer and you're getting the weight feature values, you're giving to the hidden layer and you're getting the output by using of the activation functions, bias functions here. But if you're not getting proper requirement of your output, then you can return to the hidden layers. Again you can check and again you can come to the output layer. That you can say it as back propagation. So this is about the back propagation. Now you can see coming to the next one is here so many of models will be there in CNN or apart from the CNN. We can see some particular models. So what is that particular models means? This is only first one. So here in deep learning, but why we are having these many models? We can construct the simple model, right? One model is enough, right? Why these many models will be there? ANN, BPNN, CNN, GAN, GRNN. Why these many models need? Based on your database, which database is working for more, that model you have to use. For example, if you want to work for the images, CNN, RCNN, GAN model will work very nicely and even ANN also. But if you want to work for the audio setup, GRNN, General Regression Neural Network will work more. If you're taking text based LSTM, or artificial neural network or recurrent neural network will work very nice. So how we knows means we have to check the database whether by changing of activation functions, bias functions, layers, and optimizers, everything we have to change based on the as per the past information. Artificial neural network, recurrent neural network, LSTM will work for mostly for the text based and even audio based also. But coming to the audio, apart from the GRNN, general regression will work. But coming to the image classification or video classification, so these convolution neural network will work, and GAN model will work for the generation of the new data information. So like that you are having many options. Okay, now the main important thing we are discussing, CNN, convolution neural network. In these convolution neural network, you can understand how the all layers are working to each other, how the layers are connecting to each other here. So based on the requirement, sometimes you have to use the transfer learning process also in a CNN or apart from the CNN. But layers construction should be like a CNN only. So this is one of the best CNN model. So convolution neural network model. So I will tell you the basic theory about the convolution neural network now. Then later we can see so many of models from the convolution neural network. So the convolution neural network will work for image classifications and as well as video classifications. The construction layers, you can see what you are having exactly with this particular one. So in a present days, if you want to do any image classification, these convolution neural network will work more. Now you can see the construction of the neural network I'm taking here. So this is convolution neural network. So these are the steps. So I will show you some particular picture how the layers are working, you can see here. So first I will tell you about the steps of that particular, then later you can see the next steps. Yeah, you can see the convolution neural network. This is the CNN part, convolution neural network. So what is the meaning of this convolution neural network means? This is the best option to do the image classifications and as well as video process purpose. Okay. Now you can see what are the layers are available. Now you can see if you're taking some particular data. Okay, so I'm having already data with me, I will show you. So here I'm having with me a particular data set with the train and test models. Okay, so you can gather these models, I will tell you how to go through with that. So example purpose, I'm having two type of labels here, normal and deforestation. So these are the two type of the labels for me I have. So but each and every label I'm having some particular pictures of these satellite pictures, normal and deforestation. So what is the meaning of the deforestation means if anything is affected to the forest and any constructions are occurred in a normal areas, the forestation areas, so then you have to identify that purpose. These are the normal purpose. And coming to the next one, deforestation is what they have done the making changes from the original to the normal. So these are the two labels. Now if I want to take these two labels of the data, the two labels of the data, you should apply to this convolution neural network. Then, as per our steps, you have to identify the problem is you have to classification with the deforestation. That is a problem. Then what you have to do? You have to take the data. Yes, I took the data here. After taking the data, what you have to do? So you have to select some particular model. Yes, I have selected convolution neural network. Then later what you want to do? You have to train your deforestation and normal labels data set to with the CNN model. Then only testing process will be occur. So that purpose, what I'm trying to do means how the CNN will work for this particular loading of the database means what it can do first. First it can take some particular label as deforestation. From that it will take one picture. For that it will gather the features. Then later it won't take second picture randomly. Maybe it will select a sixth picture or 10th picture, something like that. Like that, it will complete all images with the training process. But how each and every picture will work for the training with the using by using of the CNN, you can see here. For example purpose, you can see from that, just you can assume, just my assumption is like, this is from the deforestation first picture. I'm not giving the system, I mean based on the construction layer, automatically it will take. I will give entire the data with the test and train. Based on that, it will take the labels of deforestation and normal. Then it can start the process with selection of the input layer. I mean input picture. What it can do for the training of the database of the deforestation by using CNN. First, it will go to the test part. Sorry, train part. In that, it will go to the deforestation label. In the deforestation label, it can select any of the picture. That picture is there here. Example, just think like that. So you have taken this picture. Then what it can do, this is input layer. So this input layer you should give to the next layer here. What is the next layer here? Convolution. Then later you are having the pooling layer. Then later you are having the flattened layer and fully connected layer. I said input layer, hidden layer and output layer for the deep learning. That layers modified based on the model classification. So in CNN, you're having the main four layers: input layer, convolution layer, pooling layer, flattened layer, fully connected layer. Here you have to apply the all bias functions. Finally, you can get the classification process in output layer. So in input, what you have to do in input layer, you have to select the input picture. Then the input picture you should divide into the particular parts. For example, your picture will be 256 by 256. So my picture size is, example purpose I'm saying, it's not mandatory. So this is my original picture size. This original picture I'm trying to divide into four parts. That part division and all you can see in a construction of the neural network model. Okay, so like that you have to divide everything. So this is 256 by 256 rows and columns picture. Now what is the each and every part of this picture? I divided my picture into main four parts. That four parts you can call it as kernel. This is one kernel, this is one kernel, and this is one kernel, and this is one kernel. So what is the meaning of the definition of the image here? Combination of collection of the pixels or collection of rows and columns. Entire, not sum. If you're taking sum, SOM is sum, some particular sum. So I can say it as sum of collection of the pixels. I can say it as a kernel. So the original picture I'm dividing into the kernels, means I'm dividing into the parts. That you can say it as a convolution part. Then the convolution part, with the convolution part, I'm adding some activation function as relu. Okay, then after convolution part, I'm giving to the pooling layer. What it can do, what I'm dividing into the four parts, again this first part will divide into the four parts. Again that four part, first part it can divide into the different parts. Up to least part it can divide all those things like this. Why? The original picture you can divide into least part, no? Then why you want to divide into main parts? Then later you are dividing into least part, means if you are dividing the original picture directly from the particular picture, then you may get some damage of the picture. That purpose, first you have to divide into main parts, then later you can divide into each and every part should be up to least part. So these you can call it as convolution. Wherever you're converting the original picture into main parts, that you can say it as a convolution part. Then later the pooling part, that is mini pooling or max pooling, you have to take based on the least intensity value of your pixels. So then this convolution and pooling, you can say it as a feature mapping. In these feature mapping only, you can say it as a feature extraction. In these feature extraction, you're having the filtering techniques
So here, so you are having the main layers of the convolution neural network. So the first one will be input layer, convolution layer, pooling layer. So this convolution and pooling layer, you can call it as a feature extraction. Then later fully connected layer, flattened layer, and you can call it as a classification. Finally, you can see the probabilistic output. So these are the options if you want to construct the neural network. So why I'm saying this much of theory about the construction of CNN means today we are seeing the application with the convolution neural network only. So this is the architecture. So apart from that, you are having the remaining models. So in CNN also you are having so many models. How many models are available in a CNN means you are having so many of models. So CNN types. What are the CNN types means? You are having so many of CNN types. So like a mobile 92 transfer learning up to that resonate VGG. So many type of models will be there. Okay, you can see. So you're having AlexNet, ResNet, okay, VGGNet, Inception V3, and you're having so many of options like this. Okay, so ZFNet, MobileNet. So what is the meaning of this? All means in convolution neural network only, based on your size of your database or based on your construction of your database, you're having so many models in uh, deep learning of CNN itself. Okay, this is one type of model here, that is about the Google Net. So here you can see this is the Google Net architecture. It's like a neural network process only. So you are taking here Google Net process. Here you are having the multiple paths to get the output along with the inception process. That you can say it as a Google Net. And coming to the next one as VGG16. So actually VGG is nothing but, so as per the requirements of the Oxford group, they have taken these features of the hidden layers into 16, 32, 19, something like that. So VGG 16 is nothing but you are having the 16 layers in a hidden part. VGG 19 means you are taking the 19 layers of the what is that some particular layers of the hidden. So that are the construction layers. Why you are having these many models in a CNN itself means based on the specification of the space. Example, if you are taking the mobile net, it's only possible to 1 GB. If you are taking dense net model, it's only possible up to 2 GB or 3 GB. If you are taking VGG, it's possible up to 16 GB to 32 GB. If you're taking resonate model, 32, 64 also you can take. If you're taking more, you're having 128 GB option also will be there. So like that, based on your space specifications, based on your layer specification, you're having the models. AlexNet. So this is also one type of the model. It will be started by in 2019. And why the AlexNet came means, so if you are having the problems anything, and if you want to increase the layers based on your requirements, based on the kernel size, you can use the AlexNet. Okay, so like that many models will be there, like CNN with dense resnet VGG, and like that many models will be there in the CNN itself. So like that we are having many models. Now you can see the application. Till now you have seen all algorithms. Apart from that, you are having many models. So we don't have the time, that's why we have skipped some of the models. So I will tell you about architecture of GAN model at least. So we have completed today theory about deep learning models, CNN, ANN, BPNN, and in CNN so many models. Okay, so now you can see GAN model, one of the best model, not only for the AI, for Gen AI purpose. If you want to generate any new images, for example, you are seeing 10 pictures you are having, you want to get the 20 pictures from the 10 pictures means, whatever you having the original 10 pictures, that features it will do some modifications by using of adding of noise, then that you can say it as a GAN architecture. So in this GAN architecture, you're having the main options with the two options. What is that means? In GAN, you are having the two options, generator and discriminator part. So this is the option. GAN is nothing but generative adversarial neural network. In these generative adversarial neural network, you are having two models. Again, submodels type. So that is what means in these, first the generator will work for from the real data to the fake data. Discriminator will work for to train the real data and as well as to train the generated data. This is the option you can see. So you can take input random images, it can generate with the new images. That generated images you should give to the discriminator to train. Then you will get discriminator loss, generator loss. Now you have to take the real images, then you should apply to the discriminator, then it will train the new images. Okay, then you will get the discriminator loss. What is the meaning of this construction? Means simple thing. If you want to increase your particular data, if you want to increase your, for example, if you are giving like you are having like phase generations, right? Any type of generations, picture generations, there we are using the GAN model for the generation of the pictures. How it's trying to get the generation means from the original picture, it's trying to do the modifications from the original data. That you can say it as generator. So because of this GAN model, you will get the uh, what is it, construction of full GAN model, generative adversarial neural network. So how in this particular area, I said like CNN we have to use softmax activation function, loss function will be categorical cross entropy, and optimizer should be Adam, right? But here in a GAN model, what you can take means you can take leaky ReLU, and as well as linear, and as well as you can take TNAH. Okay, because for the generating process. Okay, so because it's having the linear process and non-linear process both. So like that you have to select some particular bias functions based on your construction of the model. So these are the entire requirements. But now if you want to see the application, today we are seeing the application with deforestation type. So today our application will be deforestation by using of satellite images. So like before deforestation and normal pictures you have to identify by using the CNN model. So our application will be deforestation uh, classification or detection using satellite images with the model of deep learning using CNN. So simple thing, deep learning deforestation detection using CNN model. The database will be satellite images, that's it. But if you want to do this deforestation detection using CNN, definitely we have to take some particular requirements. What is that requirement? I will tell you. Steps I will tell you later, but requirement is what I will tell you. If you want to complete the deforestation classification or detection, so you have to take the deep learning. Then deep learning, it will take the data, images data, then it will do the analysis and pre-processing, and you will get the output by using of neural network. But here, if you are taking images or videos, definitely you have to take some particular library. Yesterday we took one particular library as pandas to work for the Excel sheet, right? So today we are working for the images. So that purpose you have to take the library is computer vision. This is one of the best library to work for the vision based applications. If you want to read the image, display the image, or if you want to work any requirements about the images and videos, any requirements with the images and videos, you can take the computer vision library. So by using of deep learning of CNN and computer vision, today we are completing our application as deforestation classification using CNN. Now you can see the steps how you are building. Yesterday we have seen the steps, right? Like that today we can see the steps for the deforestation. So here we are taking deforestation classification using CNN with the images of satellite images. Okay, so for this step what you want to do, simply we have done only till now the construction of the model, but application wise how we are using we didn't see. Now we can see the first step is you have to load the data, load data, or you can say it as data collection. Then later what you want to do, you have to do read and pre-process the data, pre-process data means for excel sheet purpose maybe unwanted empty symbols or empty spaces or unwanted symbols you can remove. Then what you can do for the pre-process for your images means, so you can resize the images or you can do the conversions type of images. Okay, so what you can do in this process means, in pre-process, for example in deforestation only, first picture size will be 256 by 256, second picture size may be 256 by 300, like different type of sizes will be there. Then you won't get better accurate result when you're training the database. If you want to get the better accurate results while training the database of your deforestation data, definitely all pictures size should be same. That purpose you can use the resize. So what is the meaning of the resize means, we can increase or decrease the size of the picture. So that is the meaning of the resize. So I will show you the step like this. You can increase or decrease the size of the picture as per requirements. So coming to next one is conversion. Conversion is nothing but you have to convert original colored image into a gray image or black and white image. Why you want to convert colored image into black and white or gray image means, because sometimes you can't get the better proper accurate results when you're having the colored picture, because in a colored picture you're having so many features, but if you're converting colored picture into gray or black and white, then you'll get the less values to get the better calculations of your data. That purpose you can use conversions of your process. Now third step will be, we know very well, data visualizations. So you can do data visualizations with the graphs, and as well as you can display the pictures also, display pictures also. So coming to the next one, fourth step. So here we no need to split your data, because we'll get the data directly train test split. Okay, wherever you're getting the data, there they will give train and test part. No need to divide like a in machine learning part setup. If they are not giving, we have to divide. If they are giving means no need. So then later what you want to do, now you have to give the steps. Construction of CNN model, but it should be empty. Actually whenever you're creating the construction model, that is empty model. So we have to give here in a fourth step, you have to construct the empty CNN model, because what are you creating, it's like you are just creating the model. For example, you are taking a particular bottle, just you are designing, that's it. You're not adding, I mean you're not inserting anything, just you are doing the construction of empty model. So how the construction model you want to do, you know very well. So you have to take the input layer, hidden bias function and output layer. Like that, after construction of the CNN model, in a fifth step, we have to train database with CNN model. Just you have constructed here. For the constructed model, you should add your database. Then only the training process will complete. Coming to next one, model evaluation, or you can say it as like a test process. But test process is not possible in real-time applications in a normal manner. Okay, so for example, you're asking, you're uploading one picture into some particular website. about the skin, you have uploaded one picture. Then what it can do, after uploading the picture into particular website about the skin, it should identify the which type of skin you are having, any medicines you want to use. You're uploading the picture means, after uploading, after submitting the picture, then definitely you will get some particular requirements. Okay, hi Lakshmi, you have to use this particular medicines, you are having acne, so then you have to take some this particular creams and this particular what is it, medicines, and you have to follow this particular diet. Like that, it will give some particular details. How it's giving? I'm just uploading the picture. After submitting, I'm getting the results. How it's possible? Just you are seeing the front end part. In back end part, what it can do means, whatever you're uploading. So the back end process, test process, in a test process, how it will work, I will show you. In test process, first you have to browse input image, means problem image. Then later what you want to do after browsing the image, you have to do the pre-process. Simply in a front-end part setup, you can see only browsing of the image. After submitting, what it can do means, it can do the pre-process. Then later it can compare input features with pre-trained database features. I didn't say anywhere pre-trained process, right? How I am saying now here for the test process. What is the meaning of the pre-trained means? Whenever you're training of your database by using of the model, that you can say it as a pre-trained process. Because of that only you're getting output. Simply you're browsing the picture, then you're submitting means, what it can do in a background means, it will do the pre-process. Then later the comparison of input features with the pre-trained features of the CNN model along with the database, it will check. Then later it can give the output result. So our output result will be normal or deforestation should come. It should give the output like this, right? So these are the steps. But in real time applications, every time you don't want to train, you don't want to load like this, that purpose, whatever you have trained database by using CNN, here you should convert into pre-trained model. Example like uh, model dot JSON file, Java notations format, right? JSON file, or model dot h5 model, or YOLO models. Like that you are having many models, but here you will take JSON model or h5 model. So in real time applications, you don't want to do training process and all like this. If you are having new data, then you have to do follow these steps. If you don't have anything, then whatever you have already trained, the pre-trained models of JSON and h5, you should load into the backend step. Then you can start the test process. Now you can browse the input image, you can submit. In background, it can do the pre-process, it can compare the input features with these pre-trained model of JSON and h5. Then finally you will get the output as normal or deforestation. That is only the process. This is for training and up to this, and this is for testing process. So this is about the deforestation. Now you can see the output process results. So here I am having two coding part setup. So one is for front end part setup, one is for training part setup, and up to fifth step I am having code in main.ipynb, and sixth step I am having in main.py file. So now I will show you that particular step. So here you can see I'm having static templates test trainer h5 model JSON and something, right? So this is about, if I want to train, I want to load the database, I want to pre-process, I want to do the data visualization, I should create the CNN model, I want to get the training of database with my CNN, then I should convert into JSON and h5 models. For that purpose, I have to use this ipynb file. But to get the output results as like a real-time application, we can use website or app or user interface that will be available with the main.py. So this I'm executing now. That purpose, I just copied my path of my particular location of code. I went to the software as Anaconda prompt here. So here you can see Anaconda prompt path will be there. I want to change into my path, cd space. I just pasted my path, click on enter button. Then later I have clicked on Python space tab. So here Python space main.py key. In these only I am having the coding part set up with the front end and back end. For back end we have used Flask, Python and pre-trained models of JSON and H5 model. And for the front end part setup we have used only HTML files. For back end we used Python, Flask, JSON and H5 models. JSON H5 models we have used, these JSON and H5 models. Along with that we have used Flask and Python language for backend. For frontend we have used, so for frontend purpose we have used templates. So these are all templates. Actually here I have added some particular chatbot also. So now I'm executing the code. If I'm executing the code, I will get some particular what is it, IP address. That IP address I should copy and I should paste into the what is that, any type of online site. Okay, this IP address I should copy only single time. If you are copying double times, then it will get quicker. So here I am going to here and typing here. You can see my website will open. So this is only for sign up process. Then you can sign up. I am giving some particular random process. Then I have sign up. Then here I am signing. Okay. Now you can see. So this is my website. Deforestation detection from the satellite images using deep learning model, and extra models also will be there. But here I given two type of options. One is about deforestation detection, or you want to do any conversation with the chatbot, then you can use chatbot process. So I'm just clicking on the detection. So now you can browse the image. Then you can select the particular image, any type of image. Okay, these are the normal images. You have to select, then you can click on the detect. Then it will show the picture, then it will show the output all will be normal. So how you are getting the output? By submitting, because in a background pre-process comparison of input features with the pre-trained features by using JSON and H file, and everything is possible. So now I am taking another picture. If you are having the new database, then you have to retrain the model, otherwise no need. So now you can see the output result, it's showing it as deforestation. But in deforestation, I given some particular option. Okay, deforestation will be done. How much percentage it got done? So 37 percentage will be there deforestation in this particular location. So if you want to go to the return to home, then you can go to the return to home. Now you can click on the chatbot. So for the chatbot conversation, I just given only a small chatbot conversation. Here I'm having some particular questions. What is deforestation, and what are the main causes of the deforestation, like that. For example, I'm asking this question. What are the main causes of the deforestation? So I'm giving the question here. I'm clicking on the enter button, it's changing. So the main cause of the deforestation is include the agriculture, expansion and logging of urbanization, something. If I'm asking another question, what is deforestation? Then the deforestation is removing or cleaning of the trees and forests. So like that, if you want to do any conversation with the what is it, with the website as like a small chatbot, then you can use this chatbot. Otherwise you can stop the conversation, you can start the detection of the process. So this is about deforestation classification using satellite images using deep learning of CNN model. So hope you understand everything. If you are having any doubt, you can keep the messages in a chat box of YouTube. Then we'll give you answer definitely. After completion of the session also, we will try to give the answers. Or tomorrow, next session when we are starting, before that we will give you. Thank you. So today entire thing we discussed about the deep learning, types of the neural network of deep learnings, Then later we just seen the application, real-time application process will be deforestation detection with detection and as well as chatbot conversation. That's it. Once again, thanks to all people. Thanks for joining here.